In this video for lesson 4.4, we're going to be working on a few extra practice problems on page 110. Before we do that though, we just need to remind ourselves what a congruence transformation is. So a congruence transformation is a transformation or multiple transformations that keeps the side lengths and the angle measures of the figure the same. It's a transformation that keeps the pre-image and the image the same shape and size. And we have to be able to identify congruence transformations given a graph. So go ahead and get out your student journals. And we're going to go ahead and work on number 2 and 3 on page 110. So in number 2, it says, describe a congruence transformation that maps triangle PQR to triangle STU. It's important that you pay attention to what's being mapped to what. Based on this sentence, triangle PQR is our pre-image. So this triangle here on the right is our pre-image, and triangle STU is the image. That's important because our congruence transformation will depend on which shape is the pre-image and which is the image. So our job is to figure out how can we map triangle PQR onto triangle STU. Okay, so we're asking ourselves, can we do translation? Can we do a rotation? Can we do a reflection? Can we do a combination of any of these? Okay. So what I recommend first is I recommend looking at the two shapes and first figuring out if a rotation or a reflection is going to have to take place. Notice these two triangles are not oriented the same way. I can tell that I'm going to have to do some kind of rotation to get triangle PQR facing the same direction as triangle STU. So what I like to do is I like to take my patty paper. I'm going to go ahead and draw my plus sign over the origin with my arrow pointing up. And I'm just going to trace my pre-image. And what I'm going to do is I'm going to try to start to rotate this until it is oriented, it's turned the same way as triangle STU. So I'm going to start to rotate this. And as I rotate, I'm going to keep track of how far I've rotated. So I'm rotating counterclockwise. Right now I've rotated 90 degrees. This triangle is not turned the same way as triangle STU. I need to keep going. I have now rotated it 180 degrees. And what I can tell is that these are both oriented the same way. They're both turned the same way. Now, triangle PQR does not map perfectly onto triangle STU, but at least I have them facing the same direction. And so what this tells me is in my congruence transformation, I first need to do a rotation. And so my first step is to do a rotation. And I have to remind myself, how many degrees did I rotate? Well, my arrow started pointing up. It is now pointing down. So I need to do a rotation of 180 degrees first. And what I'm going to do for myself is I'm going to actually draw this new triangle on the graph after I do that rotation. So I'm going to go ahead and mark this new shape, this new figure onto the graph. Okay. So after my first rotation, I go from here to here. Now I got to ask myself, what's left in order to get from this new triangle, triangle P prime, Q prime, R prime, onto triangle STU. So I got to think, okay, since it's facing the same way, all I need to do now is a translation. I need to do a slide. I know P prime has to map onto S, right? P and S were both named first in the triangle. So I got to ask myself, what kind of slide do I need to do to get P prime onto S? I don't have to move it left or right at all. I just need to move it down 1, 2, 3, 4, 5. I just need to move it 5 units down. So after my rotation of 180 degrees, I need to do a translation 5 units down. So these two steps describe one possible congruence transformation that maps triangle PQR to triangle STU. There are others, but this is the one that I came up with. We're going to do the same thing for number 3. We need to describe a congruence transformation that maps polygon ABCD. So this is our pre-image. This is what we're starting with, to polygon EFGH. So first, like I said in my little tip for you, check to see if we have to do a reflection or a rotation first. Then you can always add a translation if you need to. So if I'm looking at these two figures, they're not facing the same way. They're not oriented the same. I automatically can tell that I need to flip, do a reflection to get polygon ABCD to be facing the same way as polygon EFGH. Now, when you do a reflection, you can do a lot of different reflections across different lines of reflection. All I need to make sure I do is flip my pre-image horizontally. So whatever line of reflection I pick, I need to make sure it's a vertical line of reflection. So just as an example, I guess I will use the y-axis for my line of reflection. I'm going to go ahead and reflect this polygon across the y-axis. When I do that, I know it will be flipped correctly so that I can then try to map it onto this image. So my first step in my congruence transformation, I'm going to do a reflection across the y-axis. And I'm going to actually do that on my graph. So C is 2 units to the right of the y-axis, so C prime will be 2 units to the left. B is 1, 2, 3, 4, 5 units to the right, so B prime will be 1, 2, 3, 4, 5 units to the left. D is 1, 2, 3 units to the right, so D prime will be 1, 2, 3 units to the left. A is 5 units to the right, so A prime will be 5 units to the left. I'm going to go ahead and connect my points. So I have the reflection. I now can tell that all I need to do now in my congruence transformation is translate or slide this figure onto my image. Okay. I'll just use A prime and E to figure out what kind of translation I need. Right? If you look at the order, I know that point A is going to have to map onto point E. So A prime is going to have to map onto E. So to go from A prime to E, I'm going to have to translate it 1, 2, 3, 4 units to the right, and 1, 2, 3, 4, 5 units down. Once I do that, this shape will map onto this polygon. So my second step in my congruence transformation is I need to perform a translation. We said 4 units right and 5 units down.